This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 1, Duct Design Fundamentals and the Equal Friction Method. Duct design is bookkeeping on pressure. You get the velocity, turn it into velocity pressure and total pressure. Add the straight duct friction, and size every run off one chart held at one friction rate. Heads up on one thing the handbook does not print. Equal friction is not a named method or a formula. It is simply how you read the round duct friction chart. We'll set up the pressures, work one duct example, then hit the traps. Concept 1. 3 pressures. Size each run from the airflow it carries. Velocity is flow over area. Velocity pressure follows from that velocity, with the general constant or the standard air shortcut that already carries the air density. Total pressure is static plus velocity. Keep those two constants straight. They are not interchangeable. Concept 2. The friction toolset. Straight duct loss follows Darcy, and shape enters 2 ways. Hydraulic diameter turns any cross-section into an equivalent round bore. The rectangular equivalent diameter gives the round duct that matches a rectangular one for friction, length, and airflow. In practice, the chart has already solved Darcy for round duct, so you read the diameter and convert shapes. Concept 3. What equal friction actually is. The handbook prints a friction chart, not a method. Equal friction just means you pick one design friction rate, then size every run at that same rate. Enter the chart at each run's airflow and read its diameter. Convert rectangular runs with the equivalent diameter. Because the rate is held constant, the longest run sets the fan pressure. Setup. Reading the chart. A branch carries 1,500 cubic feet per minute, and we design at an equal friction rate of 1/10 of an inch water gauge per 100 feet. Enter the chart at the airflow, run up to the design rate line, and read the diameter line that passes through that operating point. Then match it with a rectangular duct. Solve. Part 1. Read the size. Check the velocity. At the operating point, the diameter line reads about 16 inches round. Confirm it independently. Flow over area, with the area of a 16-inch duct, gives about 1,070 feet per minute, consistent with the chart. The two must agree. Solve. Part 2. The rectangular equivalent and the velocity pressure. Where a rectangular duct fits the space, an 18 by 12 has an equivalent diameter of about 16 inches, the same round size. And the velocity pressure at that velocity, using the standard air shortcut, is under 1/10 of an inch water gauge. Note it is not the same as the 0.1 friction rate. Traps. 5 ways this bites. 1. Velocity pressure is only the kinetic part. The fan fights total pressure, static plus velocity. 2. The two constants are not interchangeable. The standard air one already carries the density. 3. Velocity must be in feet per minute, not per second. 4. Equal friction is a chart read, not an equation. 5. The equivalent diameter matches friction and airflow, not area, so the rectangular duct's free area is different. Quick recall. Velocity is flow over area. Velocity pressure from the general or standard air constant. Total pressure is static plus velocity. Darcy gives straight duct friction. Hydraulic diameter and the rectangular equivalent handle shape. And the round duct friction chart ties it together. Equal friction means one design rate, every run read off the chart. Shapes converted with the equivalent diameter. Next up, Lesson 2, Static Regain, Total Pressure, and the Fan System Effect. Equal friction size the runs. Lesson 2 tracks the pressure itself. As a duct widens and velocity drops, velocity pressure converts back into static regain, and a short fan outlet duct raises the fitting loss, the system effect. Both are concepts on the same total pressure tool, not printed methods. Everything's at peprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide with every equation and common exam trap is free at peprepengine.com, link in the description. Structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.